See, axiomatic approach we have to uh, continue. That means in the axiomatic approach, what we mean is the sample space. We have a sample space, and we have many events of it: E1, E2, E3, etc. E1, E2, E3, etc. events we have. Okay. So now you see SB the sample space of a random experiment. The probability P is a real valued function whose domain is the power set of S. Power set of S means that is the collection of all possible subsets. Subsets means events. So events are on the first set or domain, events E4 etc. E3, E4, so many are there, and the range is the interval 0 1. So this is the numbers between 0 and 1, or the numbers between 0 and 1, and it is a function from uh, power set to the set 0 1. Such a function, if it is possible, that is what is probability, and it is a real valued function. That means probability of an event E1 is equal to, say, 1 by 2. Probability of an event, E2 or E3 or E4, any event. So image of an event is equal to a number falling in between 0 and 1. So 0 and 1, you can say 2 by 4, 2 by 4, like that. Okay. So this is what is probability uh, by the definition of axiomatic approach. Okay, for any event and satisfying the following conditions. Satisfying the following conditions. What are the following conditions? One is, for any event, probability of E1 is greater than or equal to 0. Probability is always greater than 0. Probability of the complete sample space is equal to 1, and E and F are mutually exclusive events, then probability of E union F is equal to probability of E plus probability of F. So satisfying these two conditions, probability satisfying these two conditions, probability is a real valued function. Okay. Now uh, another some other points which we can we which are following from the axiomatic definition of probability is that probability of an event, hmm, probability of an event, see, this is an event. Okay, probability phone TV ഇപ്പൊ നോക്കണ്ട ഇപ്പൊ നോക്കണ്ട നോട്ട് നോ വേണ്ട, അത് കഴിഞ്ഞിട്ട് കേട്ടോ, കേട്ടോ ക്ലാസ് നടക്കുന്നുണ്ട് ഇപ്പോൾ. ഓക്കെ. Probability of the following axiomatic definition of probability is that probability of an event, probability of omega 1 is always in between 0 and 1. 0 and 1 ഇടയ്ക്കായിരിക്കും probability for each omega in S. Okay. Probability of omega 1 plus probability of omega 2 plus etc. probability. Actually, this omega means probability of omega 1 means this omega, this sample space S is equal to omega 1. I don't know why it is not working. Omega 1, 1 minute. Omega 1, omega 2, omega 3, etc., etc. omega 1, omega 2, omega 3, etc. This is the sample space. Sample space. Yes. Okay. Sample space S. So actually omega 1 is an outcome. Okay. And this okay. So this is an event. Hmm? And this is an event, and event has got a probability. Probability of event, we write like this. Okay, probability of event omega 1. Probability of event omega 2 is also an event. Simple event, we say that simple event. Okay, probability of simple event omega 2. Instead of writing this probability of event omega 1, probability of event omega 2, we can just write probability of omega 1. So understand that, right? So that is what they have written like this. Probability of event omega 1 is written simply probability of omega 1. And this probability is lying between 0 and 1. That is the first point. And the probability of omega 1 plus probability of omega 2. Probability of simple events. Omega 1, omega 2, omega 3. If you add all these probabilities of these simple events, you should get 1. That is one property. Then for any event A, probability of A is equal to sigma probability of omega 1, omega I. So what is that? The third property I will once again I will explain. Suppose A is a event. Suppose A is an event. A is an event. Okay. A is an event. S is the sample space which contains n events, n outcomes. A is an event. A is an event. Suppose it just contains omega 1, omega 4, omega 7, like this. Three outcomes only, because it is a subset. So to find out probability of omega, probability of A, probability of A, the event A, then it is summation of all simple probability of simple events. Summation of probability of omega 1 plus probability of omega 4 plus probability of omega 7. This is how we find out the probability of an event. Now what is probability of omega 1? Probability of omega 1 means what? Probability of omega 1 is, you can just note down, probability of event omega 1. So this is what is probability of omega 1. And this is the probability of simple event omega 1. This is denoted by probability of omega 1. And compound event, this is an example of compound event. This event contains omega 1, omega 4 and omega 7. So to find out the probability of A, we have to add the probabilities of omega 1, omega 4 and omega 7. So these are the two points which you have to remember. And this one is just your textbook, what I explained. You can just go through that. And for this particular chapter, there is no need of much explanation, because you can understand it simply by reading this. Anyway, just explain these things in the class. Actually, I think I completed both this in both the classes. Okay. Now, next point is that axiomatic approach. See, let a sample space be S equal to omega 1, omega 2, omega 6. They are outcomes. Okay. Which of the following assignments of probabilities to each of the outcome are valid? The first assignment of probability omega 1, its probability is 1 by 6. Simple outcome has got the probabilities 1 by 6, 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 1 by 6. So how do you check if it is valid or not? Validity of the omega. It should be greater than or equal to 0. It is in between 0 and 1. Okay, every probability is in between 0 and 1. Okay, you understood? That is fine, correct. And summation of probabilities, probability of omega, all the probabilities is equal to 1. So if you add this 1 by 6 plus 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 1 by 6, 6 by 6 equal to 1, you got the sum is equal to 1. Similarly here 1 0 0 0 0 0, okay, both the conditions are satisfied, right? And what about this 1 by 8, 2 by 3, 1 by 3, 1 by 3, minus 1 by 4? Here itself you can say this is not true, not valid, because negative probabilities not existing. Negative one outcome should not have negative probability. So this is not a valid assignment point of probability. Here all are positive, and see this point, this probability 3 by 2, one outcome has got a probability 1.5. Is it correct? No. So that is that because of that probability, it is not a correct assignment of probability, you can say. And similarly you just add these probabilities 1 2 0.3 0.6 0.4 10 1.5 2.1. So the summation of probability is not equal to 1. Okay, so it is more than 1. So this is also not a correct assignment of probability. Okay, so that is one question, and after that let us see what are the points to be studied. Probability of an event. Probability of an event already we have discussed. So how do we find probability of an event? Probability of an outcome, probability of first outcome plus probability of second outcome plus probability of third outcome. Okay, probability of equally likely outcomes. This is another important point. You have to understand what is mean by equally likely outcomes. So S is a sample space of a particular random experiment. It contains how many outcomes? N outcomes are there. You see, N outcomes are there, and in these N outcomes, see, each outcome has got exactly equal probability. Suppose every omega 1, probability of omega 1, probability of omega 1, omega 1, probability of omega 2, they have got probabilities. Sometimes they will have equal probability, say small p, every uh, outcome has got equal probability to occur. Okay, omega 1 p, probability of omega 2 p, probability of omega 3 p, probability of omega 4 p, probability of n P. So every outcome has got equal probability. It cannot be always. It may not be always the same. See, omega 1 as in the previous example, omega 2, omega 3, omega 4. These are the simple outcomes. It has got 2 by 7, 1 by 7, 1 by 7, uh, 3 by 7, okay, 1 by 7. See, different probabilities are there. They are not equally likely outcomes. If the probabilities are same, then this has got probability same, 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 then such outcomes are called equally likely outcomes. In that case, n outcomes are here and each has got probability p, small p, suppose we consider. So, and not only that, there are n outcomes, and the first outcome has got probability p, second outcome has got probability p, third has got p, fourth has got p, nth has got p. And if you add the probability of all the outcomes, you should get 1. So p plus n times p, n times p equal to 1. And what is that probability? 1 by n. 1 by n. If you have n outcomes, which are equally likely, then every outcome should have the probability 1 by n. So in this case, this probability is not equally likely, whereas if it is equally likely, n outcomes are there, 4 outcomes are there, then each outcome will have 1 by n probability. So here 1 by 4, 1 by 4, 1 by 4, 1 by 4, 1 by 4. Okay, so every outcome has got same probability. This is called equally likely outcomes. Is it clear to everybody?
Yes, sir.
Next one is, I don't know how many, in which class it is completed. This board which I selected is not working now. That particular software is not working, I think. Anyway, the other board I cannot set now. Yes. Next is, in this case, probability of a particular event. Probability of a particular event. 1 minute. Probability of a particular event. See, event has m number of outcomes. See, A is equal to A is equal. A is an event, suppose. It contains, suppose, outcomes omega 2 and omega 5. There are n outcomes in the sample space. What is probability of A? You know, as I said, told you, probability of A is equal to probability of omega 2 plus probability of omega 5. Okay, probability of omega 2 each equally likely. In the case of equally likely, if the outcomes are equally likely, 1 by n plus 1 by n equal to 2 by n. If an event contains, if an event contains two outcomes, then its probability is 2 by total n. If an event contains small m outcomes and total random sample space contains n elements, then m by n will be the probability. M by n will be the probability. So number of outcomes favorable to E divided by total possible outcomes. Okay. If you understood this, you can just give me a sign. Okay. Now next is probability of the event A or B. Probability of an event A or B. What is the meaning of probability of an event A or B? Okay. So this proof you can just check it out. This proof is, this is the proof. Two proofs are given. Let us take this proof. Actually, there is no need of proof. Anyway, it should be noted. Hmm. So very easy. See, what is mean by A union B? A union B. A union B means what? Here you can see this blue area, this small area, and this small blue area. A union B, I can write A union B is equal to this entire A. Okay, A, entire A, and this total entire area A, and this small blue area. Okay, that is B minus A. So I can write A union B minus A. Okay, B minus A. Now you can understand. See this A and this B minus A. See this figure, it's total A and B minus A, this small portion, they are mutually exclusive. Therefore, probability of A union B equal to probability of A P of A plus P of B minus A. Okay, you can write like this. In the blue ink it is written. Now similarly, what is B? B, set B. Set B is the union of A intersection B. See that white portion? and this small portion, that is B minus A, its union, B minus A, right? And it can be seen that this white portion and this blue portion, they are mutually exclusive. What is the meaning of mutually exclusive events? There is no point in common, they are totally disjoint. Okay, and since it is disjoint, probability of probability of B equal to probability of A intersection B plus probability of B minus A. Okay. What is probability of B minus A from here? Probability of is not so easy to write. Probability of B minus A is equal to what? Probability of, from here I can write, probability of B minus probability of A intersection B. Okay, probability of B minus probability of A intersection B. From here, this is equal to this minus this. That is what we have written. Now, this must be substituted here. So, what you will get? Probability of A union B is equal to probability of A plus, instead of probability of B minus A, you substitute it here. So that what you will get? Probability of A plus probability of B minus probability of A intersection B. So finally you will get this result. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, and this is the rule which we have seen here. Now next is probability of event not A. Probability of event not A. Only this much we will understand now. Probability of event not A. You know, probability of, S is equal to, same way, S is equal to A union its complement. A and complement are disjoint. Therefore, probability of S is equal to probability of A plus probability of A complement. I'll show you here. Probability of S is equal to probability of C. See, probability A union A complement is equal to S. See, probability of A union A complement is equal to S. Then probability of A union A complement is equal to probability of S. Probability of A union A complement, since they are mutually exclusive, as per the axiom, probability of A plus probability of A complement is equal to 1. Probability of A complement, which is probability of not A, is equal to 1 minus probability of A. 1 minus probability of A. So you have probability of not A, not A, not A is equal to 1 minus probability of A. 1 minus probability of A. This is the next result. The first result is probability of A union probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And what about the other one? Just now we have seen probability of not A is equal to 1 minus probability of A. Probability of A complement is equal to 1 minus probability of A. Okay. So these are the theory part. And next part is problems part. That is the only thing left out. That means probability of exercise 16.3. And now anybody has got any doubt in this connection? Nobody is responding. I don't know whether you are in the class or not. Anyway, up to this only I can sit. That is why we will stop now, and the 16.3 questions we will solve in another class. That I will inform you just as I did today. Okay, thank you.